Guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular video, I'm going to look at the second part of the concept of a Gauss elimination method. And this is going to be consisting of a combination of a Gauss-Jordan elimination method. Now, in our previous video, we had considered a system of equations which was given in terms of a general form. And we had said that we can use the specific values for the, of course, matrix of A, which is n by n, considering the various types of course, values for A, which are going to be forming the specific coefficients. And we said that we can write these coefficients in terms of a matrix form, which can be given in such a kind of a form for a specific matrix for the one, just like the one which we had on the board. Therefore, for a system of equations, which for our case is going to be 3, we are going to use the specific coefficients to represent them in terms of a matrix given in such a kind of a form. So we said that this is going to be a general form of an equation of the form AX is equivalent to B, whereby we are going to have the elements of the matrix which are going to be multiplied by this, of course, the variables of X are going to be forming results of B. And we said that we can arrange them to have this specific format of the elements of the matrix times the, of course, the variables is going to be giving us these results for B. Now, in a sense, we said that we can have this one given in an augmented form, which it basically is going to be given in form of A, B, given as such. And this specific form can be reduced to an echelon form for us to have the specific variables of x1, x2, and x3 given in terms of solutions. So in a sense, this is one of the methods which we are going to use in order to find solutions of the unknown values of x. And of course, we can use this specific method by reducing the particular, of course, augmented form to an echelon form. Now, in our previous discussion, we had considered this specific equation, whereby we took the coefficients and, of course, had this one written in terms of an augmented form, which gave us this one. We performed a series of elementary row operations, which gave us, of course, a form of a matrix, which we came up at this specific point, which basically was forming what we refer to as an echelon form of matrix. And in this case, in writing this specific aspect of the equation in terms of the values of x3, which is going to be giving us the value of 3, these are going to be respective coefficients for the first equation, second, and third ones, which were given in this specific order. Now, from our previous evaluation, we found the respective values of x1, x2, and x3. And in a sense, we came up with the particular values which we obtained for this one by solving those equations given in terms of x1 equivalent to 5, x2 equivalent to -2, and we had the value of x3 given in terms of this specific value of 3. Now, in a sense, this gave us one of the ways of solving this specific for these specific variables of x by using this, of course, Gauss elimination method. Now, in the Gauss-Jordan elimination method, we are going to perform further elementary row operations, which are going to assist us reduce this specific matrix to a row-reduced echelon form, whereby we are going to have this specific aspect of identity, which is going to be forming on our left side of this specific evaluation. Now, in a sense, of proceeded from this specific point from the Gauss elimination method and involve the concept of a Jordan elimination, Gauss-Jordan elimination method, which is going to assist us reduce this specific matrix to an echelon form. And this is going to be forming this specific 2 range of elementary row operations. Now, in a sense, we are going to obtain this particular result, which basically is going to be coinciding with the previous, of course, results we had for the variables of x given in terms of x1, basically being given in terms of 5, x2 is equivalent to -2, and x3 is equivalent to 3. Now, in a sense, the Gauss-Jordan elimination method is going to be an additional concept that is going to be assisting us find direct evaluation of this specific, of course, matrices, which can be given in this specific form by having this augmented form reduced to a row-reduced echelon form given as such. So this method is going to be assisting us try also to find the specific solutions by involving the concept of a row-reduced echelon form, and this is going to be forming an additional concept. So for our member who have not basically checked on the Gauss elimination method, I like to encourage them to check a link which I'm going to put in the description box. It's going to be consisting of a range of videos, including the first one which we have done on the concept of a Gauss elimination method, and it's going to be more comprehensive for us in understanding the two concepts by having a look at those specific discussions. So kindly check our description boxes for that specific video. Subscribe and engage us in the comment section, and also ring that notification bell for other updates in our discussion in different topics. So that is it for now, guys. Bye. God bless you. Catch us in our next video.